Lacking land, freshwater, and virtually devoid of natural resources, Singapore, one of the 4 Asian tigers, allocates less than 1% of its land area to agriculture. Yet it continues to systematically produce clean vegetables, eggs, marine fish, and a variety of high-quality agricultural products to feed nearly 6 million people. So how can an island nation, with such scarce agricultural land, smaller even than Central Park in New York, build a high-tech agricultural sector that garners worldwide attention? Right now, join Agriculture Insight to explore the agriculture of the Lion City, a place where every single square meter of land is leveraged through technology, turning inherent limitations into competitive advantages and serving as a model for many land-scarce nations around the world to learn from. Let's get started. With nearly 75% of its population of Chinese descent, alongside Malay and Indian communities, rice remains the most consumed staple food in Singapore. However, rather than allocating scarce land and water resources to paddy fields, the island nation imports almost all of its rice. Instead, its agricultural land is dedicated entirely to leafy greens, eggs, and aquaculture, food groups that deliver far higher nutritional value per square meter. And now, let's step into the vertical farms, where Singapore transforms old parking garages or warehouses into urban vegetable factories, producing up to 80% of the island nation's homegrown produce. Inside these enclosed spaces, the process begins with a fully automated seeding stage. Ultrafine vacuum nozzles, measuring only a few millimeters wide, pick up each seed and precisely place it into individual substrate cells. After just a few days in the nursery, the seedlings, now sturdy enough to grow, are immediately transferred to the cultivation racks. At multi-tiered farming towers like Sky Greens, aluminum structures can reach up to 9 meters high and accommodate 38 stacked tiers of trays. Automated lifting systems and robots move each tray to its exact position, transforming a tiny plot of land in the heart of the city into a high-rise field operating year-round. To replace sunlight, LED lights run for about 14 to 18 hours a day, providing the exact light spectrum plants require for photosynthesis. But light alone isn't enough. In Singapore, this model only truly works when it solves the vital challenge of water. Drip irrigation systems deliver nutrient solutions directly to the root zone, minimizing both evaporation and waste. Excess water is then collected, UV sterilized, and recirculated, saving up to 95% of this liquid gold compared to traditional farming. Thanks to this modern process, greens like bok choy, lettuce, and kale typically take less than a month to harvest. Vegetables are harvested, packaged right on site, and distributed to retail chains in just a few short hours. The truth is, Singapore never expected local produce to be cheaper than imported vegetables. Even though prices are often twice as high as those from Malaysia, China, or Australia, each bunch of high-tech greens is still considered a strategic investment, ensuring freshness and safety while maintaining a stable supply even when global supply chains are disrupted. If indoor hydroponic vegetables still require electricity for photosynthesis, mushrooms are virtually immune to that limitation. Lacking chlorophyll, they obtain energy by breaking down organic substrates rather than relying on sunlight. As a result, Singapore can make use of all kinds of enclosed spaces to cultivate mushrooms, from warehouses and old shipping containers to even bedrooms. Here, mushroom bags are stacked in multiple tiers to maximize space efficiency. Although they don't need light, they absolutely require sufficient water and humidity, two vital factors to prevent the mushroom pins from shriveling and drying out. In traditional farms, growers still have to spray water regularly to maintain humidity for each shelf of substrate bags. Meanwhile, in sealed growing rooms, automated misting systems combined with ventilation and air conditioning continuously maintain a humidity level of around 90%, helping mushrooms develop uniformly without water accumulation that could cause disease. About 2 to 3 weeks after fruiting stimulation, farmers harvest the mushrooms by cutting the clusters close to the base without damaging the remaining spawn. They then trim the stems, package them in trays, and transport them to supermarkets nationwide. What is truly impressive is that this model is also exceptionally eco-friendly by fully utilizing byproducts. After each harvest cycle, the spent substrate bags are fed into a shredder to be ground into a fine mulch. Instead of being discarded into landfills, they enter a composting system to become organic fertilizer for growing vegetables and ornamental plants, completing a perfect green circular cycle where not a single fragment of resources goes to waste. Leaving behind the quiet mushroom rooms enveloped in darkness, let us turn to a product even more vital to Singapore's food security: automated egg production factories. With just 3 domestic poultry farms, Singapore currently supplies about 30% of its national egg demand. At Choose Agriculture, one of Singapore's most modern farms, more than 300 million eggs are produced each year. Notably, because limited land forces farms to operate close to residential areas, every stage of the poultry farming process must meet strict standards regarding odor, noise, and disease prevention. Millions of hens here are housed in multi-tiered climate-controlled coops, integrated with 24/7 monitoring sensors. Furthermore, their nutrition is optimized with feed mixed with probiotics, which significantly reduces digestive odors while boosting their immune systems to minimize reliance on antibiotics. The moment an egg is laid, an automated conveyor system transfers it directly to the processing center without human contact. Upon arrival, automated UV technology eliminates salmonella bacteria and detects microcracks, while the system sorts, washes, and packages the eggs onto trays at a speed of tens of thousands per hour, producing ultra-clean eggs suitable for raw consumption, alongside specialty lines enriched with omega-3. To thoroughly solve the urban waste problem, all chicken manure must be collected via a multi-tiered conveyor system and sent to a centralized facility for drying, transforming into organic fertilizer to feed back into vegetable farms. It is a process free of noise and offensive odors spreading to the community, and most importantly, it minimizes the risk of external disease outbreaks. It may sound paradoxical that an island nation home to one of the busiest shipping lanes on the planet, with over 100,000 vessel movements a year, can hardly farm fish at sea. The reason stems from a bitter lesson in the past, when outbreaks of red tide and oil spill incidents wiped out hundreds of tons of traditional cage-farmed fish overnight, forcing the island nation to reshape its survival strategy, moving the entire marine fish farming process into virtually enclosed, floating factories. On average, a resident here consumes up to 22 kilograms of seafood annually, well above the global average. With the country importing up to 90% of its food supply, seafood is not merely a familiar staple, but also the highest value source of fresh protein that Singapore strives to be self-sufficient in. At EcoArc, a floating farm worth over $4 million located in the Johor Strait, high-value fish species like barramundi, red snapper, and grouper live entirely in 4 massive steel tanks with a total capacity of up to 1,900 cubic meters. Notably, all seawater undergoes a strict closed-loop treatment process before entering the tanks: multi-stage, coarse filtration, UV sterilization, and ozone aeration. Thanks to this technological barrier, the fish's living environment is completely isolated from pathogens, microplastics, and pollution caused by passing vessels. While open-sea aquaculture cages rely heavily on weather conditions and natural currents, the AI system at EcoArc automatically adjusts artificial current speeds within the tanks. This continuous water movement encourages active swimming, yielding meat as firm as wild fish while allowing stocking densities to be maximized. As a result, despite its modest surface area, this floating farm can yield up to 166 tons of fish per year, 20 times higher than traditional sea cages of equivalent scale. Do you happen to thoroughly despise flies? Intriguingly, if it is the black soldier fly, a disease-free, non-biting insect with an elongated body resembling a wasp, it serves as a strategic biological weapon for Singapore. Dubbed nature's cleanup crew for their ability to turn food waste into protein-rich animal feed, they are building an industry that drastically drives down the cost of marine fish production. Insecta, Singapore's first black soldier fly biotechnology company, is located right in the heart of the bustling Queenstown urban area, adjacent to HDB residential blocks, schools, and public libraries. Even though they are native forest insects that naturally avoid populated areas, the black soldier flies here are fully domesticated within a closed-loop system that is odorless and causes zero disturbance to the surrounding community. Inside space-optimized, multi-tiered breeding trays, millions of larvae act as biological processing plants for waste. During their 2 to 3 week larval stage, they eat relentlessly, capable of consuming food waste, weighing up to 4 times their body weight every single day. Their primary food source consists of byproducts from the local food processing industry, such as okara soy pulp and spent brewery grains, reducing organic waste volume by up to 70%. After pupating and emerging as adult flies, they live for a brief period of just 3 to 7 days, just long enough to mate and lay eggs without biting or causing any harm to the surrounding environment. While drying insects for livestock feed is common in many places, Singapore pushes biorefining further to close the loop on its circular economy. The extraction line recovers 2 high-value compounds from the black soldier flies, melanin and chitosan, which are used to produce biodegradable food wraps. Meanwhile, the protein and fat are processed into animal feed powder, and the frass is collected as organic fertilizer for vegetable farms. It would not be an exaggeration to say that for every 10 liters of palm oil used worldwide, nearly 6 liters come from Indonesia. With around 45.5 million tons each year, the country controls nearly 58% of global supply, enough to make each harvest season not just a story for farmers, but something that can influence the entire international vegetable oil market. And to understand how that power is created, the journey must begin in tropical nurseries, where each young oil palm is raised in a polybag for more than a year to develop strong roots, stable leaves, and enough strength to enter the plantation. When the seedlings reach around 12 to 14 months old, they are transplanted into straight, carefully planned rows, with wide spacing to receive enough sunlight and allow easier mechanized care. About 3 to 4 years later, the palms begin entering the fruiting stage. At this point, farmers pollinate the flowers by directly spraying treated male pollen onto the female flower clusters, helping increase the fruit set rate and produce denser, heavier, and more uniform palm fruit bunches. After about 2.5 to 3 years in the field, oil palms begin to be harvested, with fruit bunches weighing from a few kilograms to more than 20 kilograms hidden deep inside the thorny canopy. In the past, on many small farms, harvesters had to use ropes or climbing belts to climb the rough palm trunks and reach fruit bunches high above. A single slip while climbing, or a bunch falling in the wrong direction, could immediately make the job dangerous. That is why, as plantations expanded and harvesting needed to become faster, Dodo's chisels and long-handled curved Y sickles gradually replaced manual climbing. For shorter palms, the Dodo's chisel cuts directly into the bunch stalk. For taller palms, the long-handled curved Y sickle allows the worker to stand on the ground, guide the blade into the right position, and pull sharply so the fruit bunch falls. Immediately after that, a tractor fitted with a hydraulic arm moves between the palm rows, using metal clamps to grab each fruit bunch, lift it onto a trailer, and begin the collection process. In swampy, sloped, or hard-to-reach plantations where tractors struggle to move between palm rows, pulleys, hauling cables, and hanging rails, are used as a secondary transport route to move fruit bunches to collection points. After being cut from the tree, palm bunches weighing dozens of kilograms no longer have to be dragged through mud or carried by hand over long distances. Instead, they are hooked onto a suspended system and slide along cables or rails toward the main transport path. This method helps reduce labor, shorten collection time, and limit impacts that can cause loose fruit to fall, bruise the skin, or become mixed with mud. For palm oil, speed after harvest is crucial because the faster the fruit reaches the mill, the more stable the oil quality becomes and the lower the loss rate will be. From there, the palm bunches are taken to the mill, where the fruit is softened with steam, stripped from the stalks, and crushed to extract orange-red crude oil. This oil flow is then filtered, cleaned, and refined before becoming an ingredient for cooking oil, margarine, cosmetics, and biodiesel. In the past, Indonesian palm oil was heavily criticized for deforestation, loss of natural habitats, and pressure on biodiversity. But those controversies also became a turning point, forcing Indonesia to reshape the palm oil industry through traceability, forest land restoration, and more sustainable production standards. When people talk about Indonesian agriculture, they often think immediately of palm oil. But few know that the country is also the world's #1 coconut king, producing around 17.97 million tons each year and accounting for nearly 28% of global output. Despite holding the leading position, Indonesia's harvest season still carries the strong mark of local experience and manual labor across its tropical islands. If oil palm bunches can often be cut down from the ground with a sickle pole, coconuts are far more difficult. The fruits grow high near the canopy, the bunches are heavy, the trunks are slippery, and the falling direction is hard to predict, so local workers must choose harvesting methods based on each tree's height. For shorter trees, they stand beneath the canopy, use a long pole fitted with a curved blade, aim carefully at the stalk, and pull sharply so the whole bunch falls to the garden floor. But when mature trunks reach around 15 to 25 meters, the pole tip easily shakes and becomes difficult to control accurately. At this point, the worker has to stay close to the trunk, using a climbing belt or a metal climbing frame with footrests to lift the body upward step by step. Once at the top, they keep their balance among the leaves, swing a knife into the bunch stalk, and begin the journey of bringing coconuts into Indonesia's massive processing chain. Unlike Thailand, where fresh drinking coconuts often dominate, Indonesia stands out for mature coconuts used in deep processing. After being cut from the canopy, each coconut is stripped of its fibrous husk right in the garden to make it lighter for transport, then gathered into large piles before being loaded onto small boats that move through the network of canals. From these collection docks, the coconuts enter modern factories, where the white flesh is crushed, pressed, and dried to produce coconut milk, coconut cream, coconut powder, and more, turning a familiar crop into one of Indonesia's high-value export product chains. Leaving the coconut gardens, the journey continues into mangosteen season, the queen of fruits in Indonesia. Each year, the country exports more than 100 million USD worth of fresh mangosteen, with about 113 million USDs in 2023 alone, turning this purple-skinned fruit into one of the most valuable tropical fruits on Indonesia's export map. Because of that position, mangosteen quality must be protected while the fruit is still on the tree. Mangosteens are often intercropped in coconut, durian, and other fruit orchards, where shade keeps the soil moist enough and protects young fruit from the harsh tropical sun. In intensive orchards, drip irrigation further maintains stable water around the roots, because the tree only produces good fruit when the soil is neither too dry nor waterlogged for too long. During the main season from December to March, mangosteens are not harvested in bulk, but must be carefully caught one by one as they leave the branch. For lower branches, the worker gently holds the stem and twists it carefully until the fruit comes free. For higher branches, a long pole fitted with a catching basket is guided into the canopy to receive the fruit the moment it is cut. Such care is essential because beneath its seemingly tough purple rind, mangosteen can easily crack, leak latex, or suffer internal damage if handled improperly. From the moment it leaves the branch, the mangosteen immediately enters the grading process in preparation for export. Each fruit is sorted by size, skin color, stem, calyx, and even the smallest surface scratches. Only fruit that meets the required standards is packed, placed into the cold chain, and shipped to China, the largest export market for Indonesian mangosteen. Before oil or precious metals dominated trade, Indonesian pepper was once a treasure of maritime routes, powerful enough to pull ships halfway around the earth to the spice ports. More than 1,000 years later, from Lampung to Bangka, this tiny spice still carries its own weight, bringing in around 148 million USD in export value in 2022 alone. And to preserve the value built over centuries, every stage of pepper production in Indonesia today must be controlled from the very first step. The journey begins in shaded nurseries where young plants are raised under soft light, stable temperatures, and just enough water to form a strong root foundation before entering the field. Once planted, each vine is placed beside a living support tree or a concrete post about 3 to 4 meters high, allowing the climbing stem to grow upward, receive even sunlight, and help farmers prune, fertilize, and control pests more easily. After only about 2 to 3 years, rows of pepper-covered posts begin entering their first harvest season and can maintain productivity for more than 15 years. During harvest season, growers do not pick at one fixed time, but choose the ripeness depending on the final product. For Lampung black pepper, the fruit spikes are cut when the berries are mature, still dark green, or just beginning to turn yellow. For Bangka white pepper, growers wait until the berries turn red on the vine before soaking them in water for several days. Once the skin softens, the berries are rubbed clean, and the light-colored inner seed is dried, creating a pepper with a delicate aroma, clean heat, and a higher value than black pepper. After harvest, the pepper is taken for processing within the same day, separated from the spikes, then sun-dried or mechanically dried. As the outer skin shrinks, the berries are sorted, ground into powder, or sent directly into the export chain. Originating from the Banteng wild cattle of Southeast Asia's tropical forests, Bali cattle were gradually domesticated into one of Indonesia's most important native cattle breeds. Thanks to their strong ability to adapt to hot and humid climates, local feed sources, and farming conditions across different islands, this breed once accounted for nearly 30% of the domestic cattle herd, helping support a fresh beef market worth around 3.7 billion USD. Unlike beef cattle in the United States or some livestock regions in Africa, Bali cattle do not overwhelm people with massive body size. Instead, they stand out in the qualities Indonesian farmers need most: strong heat tolerance, the ability to use local feed, stable reproduction, and adaptability to changing farming conditions across tropical islands. From the time they are still nursing, Bali calves are kept close to the herd to become familiar with the barn and receive careful care during the early stage. As they grow, they start eating fresh grass, then are supplemented with straw, bran, and minerals to stabilize nutrition, helping the herd develop evenly and making weight gain easier to monitor. Alongside that, many regions still maintain natural grazing, creating a farming model that combines local experience with modern management. Beyond economic value, cattle are also a source of cultural pride in Madura, where brightly decorated pairs of bulls are transformed into athletes, pulling wooden sleds across the racetrack during festivals. For breeders, victory is not only about honor, but can also raise the value of a cattle pair to around 30,000 USD, turning them into symbols of prestige, wealth, and community. To understand why the Dutch had to create new land from the seabed, we must first understand a paradox that has existed throughout much of the nation's history. With a land area of only about 41,000 square kilometers, roughly the size of the U.S. state of Maryland, and 234 times smaller than the United States, the Netherlands has long faced a limitation that many great powers never encounter: a shortage of land. Every square kilometer became a valuable resource for housing, industry, infrastructure, and agriculture. Yet limited land area was only part of the problem. The Netherlands' real enemy stood right on its doorstep: the North Sea. For thousands of years, storms from the North Sea repeatedly pushed seawater deep into the mainland. About 26% of the Netherlands lies below sea level, while nearly 60% of the country remains vulnerable to flooding from the North Sea and its major rivers. If the dike system were ever breached, water could rapidly inundate some of the nation's most densely populated regions. In other words, the Netherlands did not merely lack land. It also faced the constant risk of losing the land it already possessed. For many countries, this would have been an almost impossible challenge. A nation with limited land, a dense population, and a constant threat from the sea would struggle to become an economic power, let alone an agricultural superpower. But instead of surrendering to the limits imposed by nature, the Dutch chose a far more ambitious path: rewriting the geographical map of their own country. And that was the moment a centuries-long battle between humanity and the North Sea truly began. As early as the Middle Ages, coastal communities began building the first dikes to protect their land from storms and tidal surges. However, keeping water out was only the beginning. Their greater ambition was to reclaim land from the sea itself. To achieve this, the Dutch developed the polder system, a form of engineering that isolates a body of water with surrounding dikes and then continuously pumps the water out, transforming seabeds or marshlands into dry land. Over the centuries, nearly 7,000 square kilometers of new land were created through this method, equivalent to about 17% of the Netherlands' present-day territory. But as the population and economy continued to grow, small-scale land reclamation projects were no longer enough. The turning point came in the early 20th century with the Zuiderzee Works, one of the most ambitious engineering projects in human history. By 1932, the 32-kilometer Afsluitdijk had brought over 3,500 square kilometers of water under Dutch control, creating Lake IJsselmeer and enabling the largest land reclamation program. Yet creating new land solved only half the problem. In 1953, a catastrophic storm killed more than 1,800 people and submerged approximately 200,000 hectares of land. The disaster demonstrated that if the Netherlands wanted to survive in the long term, it needed not only to create more land, but also to control the power of the sea itself. The result was the Delta Works, consisting of storm surge barriers, sluices, and water control structures stretching across the southwestern Delta region. The Delta Works is widely regarded as one of the 7 wonders of the modern world. Even today, that battle has not ended. Its clearest symbol is the Landkering, a massive storm surge barrier capable of automatically closing when sea levels rise, protecting the port of Rotterdam and the most important economic center of the Netherlands. After centuries of battling the sea, the Dutch transformed their greatest vulnerability into an engineering triumph. Supported by more than 17,000 kilometers of dikes and one of the world's most advanced water management systems. And on those newly created lands, an agricultural revolution was about to begin. The greatest achievement of the centuries-long battle against the North Sea was not the dikes or the massive storm surge barriers. It was Flevoland. Located in the middle of Lake IJsselmeer, Flevoland is the youngest province of the Netherlands and the largest artificial landmass in the world. The entire region once lay beneath the sea before the Dutch transformed it into dry land through a system of dikes and massive pumping stations. The construction process took decades. Engineers first isolated sections of water with dikes, then continuously pumped the water out to expose layers of sediment that had accumulated on the seabed over thousands of years. The result was more than 970 square kilometers of new land, significantly expanding the development space of a country that had always faced a shortage of land. But Flevoland's greatest value was not its size. Flevoland proved that the Dutch could create land through engineering. Ultimately, the strength of an agricultural system is not determined by the amount of land it possesses, but by the amount of output each hectare can produce. And to solve that challenge, the Dutch began investing in something even more valuable than land: seeds. Creating new land was already an engineering miracle. But the strength of an agricultural system is not determined by the amount of land it possesses, but by its ability to unlock the hidden treasures within every hectare of land. With a land area less than 0.5% that of the United States, the Netherlands had virtually no chance of competing through agricultural scale. It had to compete through productivity. And the answer lay in seeds. At the center of this revolution is Wageningen University and Research, the world's leading agricultural research institution and, in many ways, the heart of the entire Dutch agricultural sector. For more than 70 years, scientists there have been researching plant genetics, seed technology, and advanced farming methods to develop crops with ever higher yields. From this scientific foundation, an ecosystem of world-leading seed companies began to emerge. One notable example is Rijkswaan, which developed a tomato seed costing less than 50 cents, but capable of producing up to 150 pounds of tomatoes over the plant's lifetime. These high-yield seeds, resistant to pests and highly adaptable to harsh weather conditions, are so valuable that they are effectively worth more than gold. Today, 1 kilogram of gold is worth around $115,000. Meanwhile, 1 kilogram of premium hybrid tomato seeds can be worth as much as $1 million. Their true value does not lie in the seed itself, but in the scientific knowledge compressed within every single seed. This advantage has enabled the Netherlands to produce around 6% of Europe's total food output, while possessing only about 1% of the continent's agricultural land. It is also the foundation that helped the country become the world's second-largest agricultural exporter, behind only the United States. But superior seeds are only half the story. To unlock their full potential, the Dutch went on to build an even more ambitious production system: a greenhouse empire. The center of this revolution lies in Westland, an area often referred to as the Silicon Valley of agriculture. From above, it resembles a vast sea of glass stretching across more than 90 square kilometers, nearly the size of the entire island of Manhattan in New York. Inside these facilities, nearly every factor affecting plant growth is controlled. Sensor systems continuously monitor temperature, humidity, carbon dioxide concentration, light intensity, and nutrient levels in the water. Computers then automatically adjust ventilation, heating, irrigation, and carbon dioxide supplementation to maintain near-perfect growing conditions 24 hours a day. Instead of growing crops in soil, many farms use hydroponic systems, allowing plant roots to absorb water and nutrients directly with near-perfect precision. Excess water is collected, treated, and continuously recycled in a closed-loop system. The result is productivity levels that traditional agriculture can hardly match. An outdoor tomato farm typically produces around 50 to 80 tons per hectare each year. In contrast, modern Dutch greenhouses can generate more than 500 tons of tomatoes per hectare, roughly 6 to 10 times higher. For bell peppers, yields are also often several times greater than those achieved through conventional farming, thanks to the ability to maintain year-round production regardless of external weather conditions. More importantly, this system uses fewer resources. Some Dutch greenhouses can reduce water consumption by more than 90% compared to conventional farming methods, while also significantly reducing the need for crop protection chemicals. This is where the seeds developed at Wageningen University and research, and companies such as Rijkswaan, realize their full potential. Few countries have transformed greenhouse farming into a national-scale industry in this way. By combining advanced seeds with high-tech greenhouses, the Dutch have turned every square meter of land into a food production machine with some of the highest productivity levels in the world. And it was this model that laid the foundation for the rise of a global agricultural export powerhouse. Thailand is currently the most dynamic durian market on the planet, holding over 90% of global export share. Meanwhile, exports from Vietnam and Malaysia are also surging, driven by the popularity of premium varieties like RE6 and Musang King. This multi-billion-dollar flow is largely directed toward China, which imports more than 1.4 million tons of durian annually, worth nearly $7 billion. Here, durian is transformed into everything from hot pot and rich savory sauces paired with meat to the filling of steaming baked pastries. But what's surprising is that behind its powerful aroma, often mistaken for a gas leak, durian is actually a nutritional powerhouse worthy of its title as the king of fruits. Packed with potassium and fiber, it supports heart health much like bananas and aids digestion as effectively as oats. So for $10, would you dare to try a tray of this unusual delicacy? Trust me, it might just surprise you. Growing durian is not just about planting a seed in the ground. It's a long-term investment where every decision can shape outcomes for decades. When grown from seed, the journey begins in the most natural way. A fresh durian seed can sprout in about a week. The tree grows strong, develops deep roots, and can live for over 50 years. But the trade-off is time. It takes 7 to 10 years to bear fruit, and each tree produces different quality, like a mystery box that farmers can't fully predict. In contrast, grafting is like taking a strategic shortcut. Farmers take branches from premium varieties like RE6 or Musang King and graft them onto strong rootstocks. The result? Trees can bear fruit in just 3 to 5 years, with consistent quality, uniform harvests, and significantly higher economic value. That's why over 80% of commercial durian farms today rely on this method. On one side is patience that stretches nearly a decade. On the other is technique that cuts that time in half. And that choice ultimately determines whether a grower is simply planting a tree or building a future green gold asset. In Malaysia, the world's second-largest exporter of durian, rubber and oil palm plantations are increasingly being replaced by durian orchards with far higher economic value. But behind this boom lies a unique biological constraint. Durian flowers cannot self-pollinate. The solution comes from unlikely night workers, fruit bats. As the flowers bloom at night, bats feed on their nectar, carrying pollen on their bodies and transferring it between trees, creating a highly efficient cross-pollination system. By midnight, only pollinated flowers remain on the branches to develop into fruit. This quiet partnership plays a crucial role in global durian production. And without bats, this billion-dollar industry might never have reached its current scale. Now, let's step into the harvest season of durian. Depending on the variety and climate, durian typically bears fruit once a year, from May to August in Southeast Asia, when hot and dry conditions reach their peak. As the tree matures, the shell changes color and releases a strong sulfur-like aroma, a clear signal that the harvest season has officially begun. However, this is also a demanding challenge in both technique and safety. A 2 to 5 kilograms fruit falling from a height of 20 meters can completely destroy its commercial value in a single impact. To reduce this risk, farmers must tie protective ropes to each fruit while it is still young. Every fruit is secured to the branch with strong natural fiber ropes, forming a safety net that keeps it in place even after it naturally detaches from the stem. What's remarkable is that this system is not only for protection, but also for harvesting. When the season arrives, farmers use these same ropes like a pulley mechanism to carefully lower each fruit, instead of climbing dangerously tall trees. At the same time, in many small-scale orchards, a more traditional method is still widely used. Workers climb trees up to 25 meters tall, use a sharp knife to cleanly cut the stem and let the fruit drop. Below, another person stands ready with a jute sack to catch it, must never touch the ground. A single impact can reduce its commercial value by 30 to 50%. The key lies in the skill of tapping the durian, an expertise that takes 3 to 5 years to master. Before cutting, the worker gently taps the shell and listens closely. A dull, deep thud signals ripeness, while a higher, hollow sound means the fruit is still unripe. Being off by just 1 to 2 days can significantly affect quality. That's why this job can earn around $20–40 per day during peak season, a relatively high income in these regions. But in return, workers must operate at great heights, facing constant danger and risk. A job where a single tap, a single cut, can determine the value of an entire harvest. From here, a 2-person team can harvest hundreds of fruits per hour, amounting to hundreds of kilograms of durian, carefully loaded onto trucks for transport to wholesale markets or processing facilities. Notably, every fruit must be placed upright with the stem facing upward. This seemingly simple technique is actually a clever way to protect the fruit during transport. Keeping them upright stabilizes their position and prevents tipping, avoiding the risk of one fruit's spikes puncturing another. After harvesting, durian is quickly transported to nearby collection points for initial sorting based on size, ripeness, and variety. Here, selected fruits are carefully loaded onto large trucks. From these collection points, durian is continuously transported to wholesale markets or processing factories within just a few hours, ensuring its freshness and distinctive flavor are preserved. Before entering modern processing lines, take a moment to visit a bustling market. where the art of opening durian is performed with precision using just a single knife. The vendor inserts the blade into the base and gives a slight twist, causing the natural seams to split open as if unlocking at the exact point. The knife then glides along the ridges, opening the shell quickly without damaging the flesh inside. In just a few decisive movements, the rich, creamy pods are revealed, dry, firm, and almost separating from the seed on their own, a clear sign of perfect ripeness. The best segments are kept intact and neatly arranged into trays for immediate sale or packaging. At large markets like Ortorkor Market, a skilled vendor can handle over 300 fruits a day. For them, each cut is more than just technique. It's a blend of experience, instinct, and speed, turning a spiky fruit into perfect servings in mere seconds. Instead of heading to traditional market stalls, premium durian is transported directly to modern facilities, where it undergoes strict inspection and processing for export, with prices reaching up to $150 per fruit, several times higher than farm gate prices. As soon as they arrive at the facility, each batch of durian is handled by experienced workers for initial sorting, where size, ripeness, and shell structure are assessed by hand. Only fruits reaching 80 to 85% ripeness, the optimal range to ensure stable texture and peak flavor after transport, are allowed to proceed further down the line. Next, the selected durians enter an automated washing system, where 3 to 5 tons are cleaned every hour. High-pressure water jets combined with rotating brushes penetrate deep between the spikes, thoroughly removing dirt and impurities from the rough outer shell. After completing the drying process and passing biochemical tests, each durian is labeled with a unique identification tag to establish a global traceability system. To minimize damage during handling and transport, every fruit is placed in sturdy carton compartments designed to absorb impact, preventing bruising or broken spikes. The entire shipment is then sealed and assigned an export batch code before distribution. Alongside whole fruit production, batches of durian designated for processing are sent to the peeling section. Here, technicians carefully extract the valuable flesh from the spiky shell by making precise cuts along the fruit's natural seams. As the first cuts slide into the grooves, the tough outer shell reveals little at first. But once the blade reaches the thick white pith, about 2 to 3 centimeters deep, nearly tasteless yet essential for holding the segments in place, the durian pods begin to emerge clearly along the cut lines. Despite this dense compartmental structure, durian's characteristic sulfur compounds easily diffuse through microscopic gaps. This property is so potent that even an intact fruit can release its aroma across dozens of meters in a short time. To ensure consistency across industrial batches, extracted durian flesh is sent directly to the lab for quality control. Technicians measure the Brix level to determine sweetness and test the pH to assess freshness and product stability. Only batches that meet strict standards, typically around pH 6 and a Brix level of 20 to 25%, are allowed to proceed to further processing. From here, the process splits into separate production lines depending on the final product. A large portion of premium durian is directed into rapid freezing, a technological breakthrough that allows global export while preserving its fresh taste. The durian pods are carefully arranged on trays and sent into freezing chambers at extremely low temperatures, typically between -35° and -40°C. Within about an hour, high-speed cold air rapidly locks in freshness, flavor, and texture. In this hibernated state, the fruit's cellular structure is preserved, allowing durian to be transported worldwide while maintaining its soft, creamy texture and rich taste, almost as if it were freshly thawed. For premium ready-to-eat products, durian flesh undergoes freeze-drying in a vacuum environment. But why must water be removed at sub-zero temperatures instead of using heat? The answer lies in sublimation, a unique physical process that occurs under low pressure. Unlike conventional drying, where water evaporates through the liquid phase and can cause cell shrinkage, color darkening, and loss of aroma, freeze-drying removes moisture directly from solid ice to vapor, preserving the original structure almost entirely. As a result, over 95% of the moisture is removed, yet the shape, color, and flavor compounds remain nearly intact. The final product is light, crispy, and airy, but once it melts in your mouth, it delivers a taste and texture remarkably close to fresh durian.